Morning. Today is December 13th. Today we're going to start a new chapter. Okay. See, so far we have done these things in very detail. And of course, we have to limit the size of the systems because the amount of material that we have to input in the computer by hand, it's limited. But now we can go on to the next step. You know what is happening inside a computer program, right? At least a general idea. So let's do it. Let's use now a computer program, a commercial package. That's what we're going to start today. Okay. I posted yesterday. There is somebody called Toshiba in the waiting room, Isaac. There is a file which I posted yesterday in the seed web. Please download it and have it available, have it at hand, because that's the material that Engineer Isaac is going to explain this morning. So those of you who get the material last night, did you have any problems installing ANSYS in your computer program? Ms. Larrea, did you install ANSYS in your computer program, in your computer?
Good morning, doctor. Yes, yesterday installed the program.
Okay, so no problem, good.
No.
Okay, I'm glad. Mr. Wacon? Mr. Wacon?
Yes, I heard.
Did you install ANSYS in your computer?
Yes.
Oh, good.
Yes.
Was it easy? Was it easy?
No, is for my connection is not very good.
Okay, so try to arrange it, because one of the things I have to do is I have to check that all of you have practiced enough in order to approve this class. So you have to show me that you have some master in using ANSYS, the basic things. So the only way to do that is to reach that point is to practice. That's the only way I can test. Okay, so please, everybody should have access to this program. Okay, in the short PDF file that I gave you, it is mentioned that there are 3 elements, right? Do you remember what those elements are, Mr. Matute? Mr. Matute, do you remember the 3 elements that we have available? Mr. Matute?
Good morning, doctor. I don't remember.
I remember. Mr. Zambrano, do you remember the 3 elements? Mr. Zambrano?
No, doctor, sorry, I did not remember.
No, don't say sorry. Mr. Jimenez, do you remember the 3 elements that we have available?
Yes, doctor. A plate and solid.
Okay. So
yes.
when you see an instructor, people, when you see an instructor, there is no way we can analyze it exactly as it is. We never can do that because it's so complex. So what we have to do is we have to simplify it. Okay, that's what we call model, right? For example, when you see something which is very flat, we can model that as a plate. That means that we include certain simplifications. Okay, immediately remember when we studied plate bending in ship structure. Okay, we said we will be worried about tau xy, but we neglected tau xz or tau yz. That's a simplification. That's modeling. So you are representing that flat part of the structure using these plane elements. And these plane elements include certain simplifications. Okay, in the same token, if you have something with very long pieces, okay, you can say, okay, that's like a beam, or that's like a bar, or a shaft. okay? And if you say that that's a bar, that means that if you make a cut and you consider that in this section, the normal stress is uniform. Is that real? No, that's a simplification. That's implicit when you say that's a bar element, that's a line element, okay? It's not realistic, but that's the things that we have to do in order to be able to analyze, okay? So in order to do this modeling, this simplification, we have three elements in our library. That's a common word, okay? See, there are programs which have more or less elements in their library. The three basic elements are these, okay? Line element with definition of two joints. Believe me, you can have more complex situations. Okay, you can have a beam defined with three joints. It is a higher order element, but in our case, ANSYS usually only uses two classically. Or if you have a flat area, you can represent that. You can model that using flat elements, plate elements. These plate elements, as it will be explained by Engineer Isaac, could support in plane stresses like in chapter 3, or could apply lateral load like as we did in ship structure course. Or you can say that the three dimensions in a body are important. For example, if you want to analyze an anchor, right? It's so, I mean, the three dimensions are very important. Or a hook is a classical. So you have to think that this is just a solid. So you have to split it, partition the domain. It's a 3D, it's a solid, using this little, I don't know, what's the word for that? It's not a square. What's the name of the figure in English? What's the name of the figure? It's the basic, it has 8 joints. Okay, somebody can help me? What? A cube. It's like a cube, right? So
Hexahedra.
Hexahedra or a cube. So you can have an structure which has the 3 dimensions are very important, and you can break it. And each one of these elements is a cube. Okay, so that's one of the things that you have to do before going on. Okay, so let's please, when I give you the material, try to make a quick review before class so we can go a little bit faster, because this is very easy material. Okay, so so we can save some time. Okay, now I'm going to give the word to Engineer Isaac. He will explain the whole thing. Okay, go on, Isaac, please.
Okay. Sure. Okay. Good morning, student. So, so far you have reviewed the final element methods applying in the bar elements, in the beam elements, plates, right? So now you know the process to do the K matrix and form the big matrix and obtain the result like deflection, rotations, reaction force, stresses, strain. So you know that. So in this part, in the last 2 chapters, we are going to apply a computer package. In this case, this is ANSYS Workbench to apply final element method, right? So this is the versions that we are going to use is 2021 R2. It's easy to install. You have to enter to this link and download the driver and install the driver, right? Try to use a good computer with a good capacity. Try to delete some programs or some file that you don't use in this month in order to have more storage. Okay, so this is an application, an example for the ANSYS Workbench. So you can input all the shape in the tactile structure and analyze the shape. So you have to input the boundary condition and certain load, for example, the pressure of the button, and analyze this structure. For example, you can see both deflection in this part and due to the pressure of the button, right? So similar to this, you have to do in your project. So, but in this case, you have to analyze part of a ship. So your future work, you have to draw part of a ship and apply boundary condition and load and analyze the result. Okay, so that's an example, an application. So the model that we'll use is called tactile structural. To apply final element method, you have to complete these three parts: pre-processing, processing, and post-processing part. Okay, the pre-processing part consists to generate material. This means that you have to input the mechanical properties of the material, right? The second is include sectional properties. So in this case, there are many beams with different sectional area. So you have to include that. Assign the material. For example, you have to assign the material that you create in the geometry that you draw. General mesh is very important because this means a conveyor of the solutions. So if the mesh is very small, so you obtain a better results. But the cost of the computer is higher. That you have to keep in mind that. Okay. And finally, for the pre-processing part, is check connection between elements. If your structure is have more than one element, you have to check the connection. For example, if you have a plate with several stiffener, so the stiffener are welded to the plate. So in order to model in the program, you have to check the connection in the mesh. Okay, so always if your structure is more than one element, you have to check connection between elements. In the pre-processing part, the second part, this include boundary conditions. So you have to put if the edges or if the face is fixed support or simple support or the free support or the guided support, you have to think about it, and then apply load. There are different form to apply load is the load is a uniform, is a punctual form, or if the load is applying in the face or in a line. So there are different forms to apply loads. And then you have to execute. So this means that you have to set up the result that you want to see. For example, if you want to see stresses or equivalent stresses or normal stresses in any directions, deflections, I don't know, for reactions. So you have to set up in this part. And then post-processing part, the result that you obtain, you have to analyze what is the structure, what is the element that can fail, what is the maximum stresses, what is the minimum stresses, the maximum deflections. So you have to analyze that part, okay? And then in the program, you can extract information using certain tool, okay? So this is subchapter. This is a preparation to geometric plan. There are two forms to draw the geometry. The first option is using design model from ANSYS. So you can enter, you can input in the geometry and use this tool to draw the geometry. And the second option, you can use other program, for example, Rhinoceros or SolidWorks or Inventor, in order to draw the geometry. Then you can import this geometry from this program to the ANSYS. In this course, we're going to, in the next slide, I'm going to explain how to do certain geometry in Rhinoceros and import from Rhinoceros to ANSYS. Okay. As a doctor says, there are three types of elements: lines, plane, and solid. The lines elements is formed by two joints, and the analysis that we're going to obtain is, or we're going to do, is axial, bending, shears, and torsions. So in this part, you can see a bridge formed by several beams. So you can see, for example, this element formed by two joints. Okay, this element. So this element is formed by two joints, and the sectional and the cross section is I-section beam. So in the program, you can select, depend on the exercise, you can select the cross sections: rectangular, circular tube, channel section, I section, C section, L section, T section, and so on. Okay, this is the type, the lines to apply in the bar or beam elements. Okay, the second type of the element is a plane, but this is formed to 4 joints at least, and the analysis that we can apply is in plane and bending plate. Okay, so this is an example, and this is a plate with several stiffener in this direction, and this is a longitudinal girder in the other directions. And finally, the third type of the element. The last one is solid, formed to 8 joints. Okay, so and in this case, when I draw the geometry, so I draw with the thickness of the structure. So in the previous one is just surface, but in solid you can see the thickness. So in more detail, you can see this word. For lines, there are you can see these three type of element lines. So you can see these beams formed by two joints, and the high order two joint with intermediate points. So the second element type is plane or surface. So you can use triangular or quadrilaterals. So the quadrilateral have 4 joints, or in the high order 4 joints in the corner, but with intermediate node or intermediate joints in the edges. Similar for the solid elements. For example, you can in the program use regular hexahedral, but in some case the program use hexahedral, but with intermediate joints. For example, to this. I show now, right now in the program. You see, for example, one moment. This is the second type. This is surface, just surface, without thickness, just surface. So when you do the mesh, you can see the nodes, the joints. So in this form, maybe let me share. For example, to this. But in this case, it's just in the surface. So you see the 4 joints, but in this case, is in the high order. So 4 join in the corner, but intermediate point in the edges. Okay, this is surface, second type of the element. When you draw solid elements, for example, if this is this. So you see that this is solid. You can see the thickness of the plate. When you do the mesh, you can see the node. So let me select part of one element. So you see
Joints.
8 joints, but in this case with intermediate nodes in the edges. So if you have in your structure more nodes, so the operations is more higher. The time is more higher to run with this program. Okay, that's it. Go on to the slide. Okay.
Isaac, ask if there's any questions.
Okay, there are any questions? Are there any questions? There are any questions, students so far?
Okay, would you please go back to slide number 2?
Okay. Slide number 2. Okay.
Please, in the analysis of results, okay, yes, you have to analyze results. Remember, 2 questions. Those are the questions that you have to ask yourself for the analysis of results before concluding that your structure is safe or not. You have to check convergence. Okay, you have to ask yourself, have I converged close enough to the correct solution? And second, you have to ask yourself, does this, you will see that there are many colors, beautiful colors and all of that. Does this make any sense? So there has to be some ways to check your results. Now, for example, if you have a plate, even though it is not clamped, even though it is not simply supported, there are always ways that you can have a general idea of the level of stress, for example, or deflection that you can expect. So try to do these little checks, okay, in different parts of the structure. So you are certain that the model is correct. Then you can proceed and see if the structure is safe or not. But first 2 things that you have to answer is first, convergence. And then, does this make any sense? There has to be some way to check it, and then you can go on. Okay, in the next slide, one more. Yeah, I made a mistake. Yeah, I put in the central part, I put 4 joints. And I think the common way ANSYS partition the structure when you have surfaces is using triangular elements, not quadrilateral elements, as I said there. So the simplest way that you have in ANSYS to partition surfaces is using triangular plane elements as the one that we used in the preview in this homework. Okay, so that's an error there. So I'll correct that later on. Go on, Isaac.
Okay, doctor. Okay, now I'm going to explain an example that this is a bridge composed by bar and element. Okay, this is a bridge with the unsupported span is 10 meters and the height is 5 meters. So all elements are built from American Standard Steel I-beams, and the cross section is 8 per 4 inches, and the weighting is 23 pounds per feet. Okay, and now I'm going to explain using this slide, and then I will do in the ANSYS program. Okay, so first, you have to drag the structural module in the sketching and draw this line in this form. So when you notice when you draw these lines, certain letter can appear. If the letter P appears, this means that you select a point. If the letter C appears, this means that you select a line. If the letter H appears, that the line is horizontal, and the letter V appears, the line is vertical. So the next step is to assign the dimensions in this line. So So then you have to click on dimension and assign vertical and horizontal dimension. So in this case, this is the horizontal dimensions, H1, 2, 3, and 4, and the vertical dimension V5. So after that, you have to input the value. So remember that the unsupported span is 10 meters. So therefore, each dimension is 2.5 meters, 2.5, 2.5, go, etc. The V5 is 5 meters. The next step is to click on modeling, select the sketch once, and create a line from sketches. And then you have to click on apply and generate. So you can see that this part appears, line body. And then you have to assign this line body the cross sections. So in order to assign cross sections, you have to create a cross section for this line. Okay, in this case is I sections, so you have to input this value to form the cross section. This is I section beams. And finally, you have to assign this line body, these cross sections, and then generate. So the final results, you see that this is the bridge draw using bar and beam element. So if you use the tool view cross section solids, you see the structure, this line with the beams. Okay, so doctor, I don't know if right now.
Yeah, it's a good time to make a break.
Okay.
People, if you did not install ANSYS last night, now it's a good time to do it. Okay. Also, for those of you who did install ANSYS last night, review what Isaac just explained. Okay. So when we return, he will go one step at a time so you can follow him. And if there's any problem, you can ask him. He will try to explain you how to solve the problem. Okay, so we'll go step at a time. Okay, so for those of you who want to go on, he's using Design Modeler, which is in ANSYS. Okay, so otherwise just wait, and when we return, Isaac will explain one step at a time. Okay, so let's take a break, 5-minute break, and please, those of you who have not installed ANSYS yet, do it in these 5 minutes. Okay, so let's take a break now.
Doctor.
Yep.
I have the version of the ANSYS 17.1, I think, and it's necessary to update the ANSYS 2021.
Isaac.
Yeah, because when I check your work or your homework, and the compatibility of this program is not the same that my program. So you have to install this version.
Okay,
Yeah, okay.
if you want to do it, later, that's fine. And what we can do is you can follow the example today with your version. But after class, try to install the new version, because as Isaac said, if, for example, if we want to share an example with you, Isaac is working with a new version, the release 2. So he will just send a file and you will not be able to open because you have an older version. Okay, so please, yeah, I know it's difficult, but that's what we have to do. Okay, so if somebody has an older version, for today's session, I think we can go on with example. But for the next sessions, please try to install the new one because that's the one that we're going to be using. Okay, let's take a break.